Okay, let's look at the section 9.5 continued. Alright, so let's try to prove this couple of theorems. Alright, so let's say f is a function from a to b, and g is a function from b to c. Right? Then statement 1, if f and g are both 1 to 1, then composition g of f is also 1 to 1. Right? So let's try to prove that. Right? So in order to show that g of f is 1 to 1, we need to show that if you look at when g of f of, say, a1 is equal to g of f of a2, then this must imply that a1 is equal to a2. Right? So let's prove that. All right, so first conclusion is it's a given. F is 1 to 1. Line 2, G is also 1 to 1. So that's easy. So those are a given condition. All right, so let's assume that G of f of a1 is equal to G of f of a2. Right? All right, so that's the hypothesis of the definition of 1 to 1. So this is just, I'll just say given. Right? Then our goal is to show that at the end, a1 is equal to a2. All right, so by definition, g of f of a1, we can write it as g of f of a1, right, in this notation, and is equal to g of f of a2. Right? So this is, I'm using line number 3, and of course I'm using the definition of the composition of functions. All right, then since g itself is 1 to 1, whenever g of f of a1 is equal to g of f of a2, this inside f of a1 must be the same as f of a2 because g is 1 to 1. So this tells you that f of a1 is equal to f of a2. Right? So this comes from line 4, and also it comes from the fact that the g is 1 to 1. So I'm going to say, right, g is 1 to 1 from line 2, and I'm applying that to line 4. Right? All right, but when you have f of a1 is equal to f of a2, since f is 1 to 1 by itself, we know that a1 is equal to a2. Right? So I'm using the fact that f is 1 to 1 by itself, and using line number 5. Right? So therefore, we could show that if g of f of a1 is equal to g of f of a2, implies a1 equals a2. So therefore, g of f, composition g of f, is also 1 to 1. Right? So I'm using, say, line 3, implying line 6, and of course using the definition of 1 to 1 function. Right? So that's the proof for the first one. Right? So if two functions are 1 to 1, then the composition is also 1 to 1. Right? Number 2, if f and g are both onto, then composition g of f is also onto. Right? So what we need to show is for all elements, say C in set C, right? Because codomain of this composition is C. There must exist an element A in set A, because that's the domain of this function, right? Such that G of f of A will be exactly equal to this C right here, right? So that's what we need to show, right? First line, f is onto, that's a given, and G is onto, that's a given, right? So line 3, let's say, so it has to be true for any C, so I'm going to say choose any arbitrarily element C in the set capital C, right? So this is given, right? Since G by itself is onto, there must exist element B in set B such that G of B is equal to this element C, right? So I'm using the fact that, let's see, G is onto, so it's a 2, and also 3, of course, right? But since B is in B, since F is onto, there must be some element A in A, set A, such that F of A will be equal to this B. So I'm using the fact that F is onto by itself, and the B's in set B, so I'm using line 4. Right? So combining 4 and 5, so I'm combining line 4 and line 5, we can say this, right? For any element C, there exists the same element A in A, such that if you look at the G of F of A, right, this will give you, right, I think I need more room here. All right, this is the same thing as G of F of A, right? But from line 5, F of A is same thing as G of B. But from line 4, G of B is C, right? So I'm combining line 4 and line 5, right? So that's for line 6, right? Right. So therefore, we could show that G composition G of F is also onto, right? So I'm using line number 3 and line number 6, right? And of course the definition of onto function, right? That's it. I hope that this was clear.